Hello and welcome to the Chemistry Academy. In this video we're going to be going over the two types of bonding that you predominantly learn about in National 5 Chemistry within the bonding and structure topic. So those two types of bonding are ionic and covalent. You also learn about a type of bonding called metallic bonding, but you tend not to really talk about that until you get to Unit 3. However, I do have a video that summarises all the properties of all the different types of bonding and structure that you can go and check out as well if you are looking to kind of see how all the three different types of bonding within compounds relate to each other and what their different properties are. So if we just look at ionic and covalent in this video, like I'd said, now the type of bonding that occurs between atoms is all to do with the type of atoms that are bonded together. So firstly, the main reason that atoms form bonds in the first place is to obtain a stable electron arrangement. So that is why the noble gases, group 0 in the periodic table, don't form any bonds because they already have a stable electron arrangement, i.e. a full outer shell. So every other atom, or atoms of elements in the periodic table, are trying to obtain a stable electron arrangement like the noble gases. And they do that by reacting with other atoms in order to gain or lose electrons in order to stabilize themselves. If you want to refresh your knowledge on like how many electrons different atoms lose or gain when they are becoming stable, then you probably want to go and check out my video on ions because I explain in more detail there how that happens. The other thing to note about bonding is that it's only the valence electrons that are involved in bonding. So the valence electrons are the ones on the outside. So if we look at this atom of fluorine here, the valence electrons are just the ones in this outer ring. And you can find how many valence electrons an atom has by looking up the electron arrangements page in the data booklet. So the number of valence electrons will just be the last number in the data in its electron arrangement. So for example, fluorine, its electron arrangement is 2,7, which means it has 7 valence electrons. Lithium, its electron arrangement is 2,1, so it has 1 valence electron. So if we have to start looking at the types of bonding then, so firstly we've got ionic. So ionic bonding happens between a metal atom and a non-metal atom. So in this instance, the metal atom usually is always trying to lose electrons to become stable, and the non-metal atom is trying to gain them. So that's like a match made in heaven because the metal atom can then give the electrons it's trying to get rid of to the non-metal atom which is trying to gain electrons to become stable. So that's exactly what happens. The metal atom gives an electron or electrons to the non-metal atom. How many electrons are given, again, is depending on what the atom is. So like I said, have a look at my video on ions to brush up your knowledge on that. But lithium needs to get rid of its one outer electron. Fluorine needs to gain one electron. So lithium gives an electron to fluorine. Essentially what happens is this outer electron, the valence electron here, ends up going over here and pairing up with this electron, this unpaired electron in the fluorine atom here. So that means that lithium then ends up with an electron arrangement of 2 in the form of Li positive, and the fluorine then ends up with 8 outer electrons to form the fluoride ion F minus. So when this electron transfer happens, you end up with two oppositely charged ions forming. So like I said, the lithium's positive because it's lost an electron, the fluorine's negative because it's gained a negative electron. And then those oppositely charged ions are what we would call electrostatically attracted to each other. So remember, opposite charges attract, so positives and minuses are attracted to each other. If those ions are close enough, they will be attracted to each other, and then therefore they end up forming this sort of structure called an ionic lattice structure. So this is the structure of an ionic substance when it's a solid. If we then dissolve it in solution or make it molten, then what happens is these ions float around on their own, so this structure kind of breaks down and you end up with the positive ions and the negative ions just kind of floating around separately. They are still attracted to each other in an aqueous or liquid state, but they don't stick together in this big grid like they do in the solid form. Okay, so that's essentially how ionic bonding works. Electrons from the metal atom are given to the non-metal atom. That then forms two oppositely charged ions, which are then electrostatically attracted to each other. Then we come on to covalent bonding. So this is where we've got two non-metal atoms bonding together. Now, non-metal atoms, like I said before, are always trying to gain electrons to become stable. So in the case of two non-metal atoms, it's not a match made in heaven like the metal and non-metals where one's trying to lose and one's trying to gain. They're both trying to gain. So what they do, and it's actually quite nice, is they end up just sharing. So they just share electrons instead. So this fluorine would say to this fluorine, look, I need an extra electron, you need an extra electron. Why don't we just share an electron? So that we can both pretend that we've got a full outer shell, and that's essentially what they do. So atoms will share a pair of negative electrons, and that shared pair of electrons makes a covalent bond. If you have two shared pairs of electrons, then that equates to be a double bond, and then three shared pairs of electrons would be a triple bond. So for every one covalent bond, that's one shared pair of negative electrons. And the reason these hold together is because their positive nuclei both have a mutual attraction for the bonding pair of negative electrons. So the positive charges here are attracting these negative charges, which then holds the whole thing together. Okay, so that's how covalent bonding works. It's a shared pair of negative electrons between two positively charged nuclei. Okay, and as far as that goes, that's essentially it. They just overlap and share a pair of electrons in order to give them their full stable electron arrangement. So if it was to cover up this fluorine, you can see this one has got 2, 4, 6, 8, which makes it stable, and then this fluorine has got 2, 4, 6, 8, which makes it stable. Because of this need for stability, there are 7 elements that exist as diatomic molecules, or so we call them the diatomic elements. So you won't find them on their own as single atoms ever unless they're in a compound. So if you could get a single hydrogen, for example, if it was in a compound, but just as an element form, it has to be paired up with one of its own atoms. And these are the 7 diatomic elements here. There's a few different ways you can remember what they are. You can either remember the word Hinkelbroth, which is the word I like to use to remember them. So Hinkelbroth gives you the first letter of, basically gives you the symbols of the 7 diatomic elements. You also have the mnemonic, oh never fear, have ice cold beer. So cold and beer is for the chlorine and the bromine. So that again gives you the first, like the element symbols of the 7 diatomic elements. The other way you can do it is start from element 7 and draw a number 7. So you go from nitrogen to oxygen to fluorine, and then down to chlorine, bromine and iodine. Then that gives you 6 of them. So then you just need to remember that hydrogen that's on the other side is also diatomic as well. But like I said, Hinkelbroth is my favourite for remembering them. So anytime you're writing hydrogen, iodine, nitrogen, chlorine, bromine, oxygen or fluorine as an element, it always needs to be 2 paired up. When it comes to how many bonds substances make, it's important to know the valency pattern. It's very helpful. So the valency is just how many bonds the substance can make, and there's a pattern that goes across the main groups. So the transition metals don't have set valencies. They can form different numbers of bonds, so they kind of get skipped in this pattern. But anything in group 1 has a valency of 1, anything in group 2 has a valency of 2, group 3 have a valency of 3, group 4 have a valency of 4. Then when we get to group 5, which is the group that's got nitrogen in it, then that then starts counting down. So group 5 have a valency of 3, group 6 have a valency of 2, group 7 have a valency of 1, and group 0, the noble gases, have a valency of 0 because they don't make any bonds. Okay, so it's a good idea to write this pattern above the groups on your electron arrangement page in your data booklet. Just helps it serves as a reminder while you're doing it, doing any questions and things until you get to your exam. The other thing that's also good to write on that page is then how the valency then translates to the ionic charges. So all of this information is very important when you start to do chemical formulae, And if you again need to brush up on your chemical formulae knowledge, you can find my writing chemical formulae video on my National 5 Chemistry playlist. But if anything in group 1 has a valency of 1 and then a charge of positive 1, anything in group 2 has a valency of 2 and then therefore a charge of positive 2, and this is because they've lost 2 electrons to become stable, and by losing 2 electrons they form 2 bonds. So group 3 have a valency of 3 and then a 3 positive charge, because again they've lost 3 electrons to form the 3 bonds that they need to become stable. Group 4 have a valency of 4 and they tend not to really form ions, so you don't really need to worry about an ionic charge for them. Group 5, again, like I said before, make 3 bonds, and because they've gained 3 electrons to make those bonds and become stable, then they end up with a 3 negative charge. Group 6 have a valency of 2 and therefore a 2 negative charge because they'll have gained 2 electrons in the process of forming their bonds to become stable. And then group 7 have a valency of 1, which is a 1 negative charge because they tend to have gained 1 electron in order to become stable. And then obviously group 0 have a charge of 0 because they don't form any bonds, so they don't lose or gain any electrons because they already have their stable electron arrangement. Okay, so what I'm going to do now is talk you through the experiments that we sometimes do to show the properties of bonding, because there's ways we can identify which type of bonding is in a substance other than just knowing what elements or what atoms are made up of it. So I'll clear this off, get those notes up, and we'll get carried on with that. So in terms of the experiments around testing to find out what type of bonding you've got in a substance, we usually use the test for conductivity. And when you're testing with conductivity, you need to first of all test the substances as a solid and then test them as liquids. So molten is another word that you'll hear or see, so molten or in solution. Okay, now so you set up this little circuit, so you've got your battery, you've got a bulb, and then you've got your substance within that circuit. Now, if your substance conducts electricity, your bulb will light up. So you're essentially connecting up the circuit and looking to see if the bulb lights up or not. The types of bonding that can conduct as a solid is only metallic. So no, I've not described metallic bonding in this video, but like I said, you can get a description of it in my summary of the properties of bonding video. So metallic bonding will conduct as a solid, but ionic and covalent will not. So if you put a solid in a circuit with a bulb and the bulb lights up, then you can conclude that it must have metallic bonding in that substance. If it doesn't light up, then you know it's either ionic or covalent. To then decide between whether it's ionic or covalent, you would then test the substance as a liquid or in solution. So again, it's the same setup, but instead of having the solid in the circuit, you've got a beaker with some electrodes that go into your solution or your liquid. Again, if the bulb lights up, it means your solution will conduct electricity. Solutions or liquids that can conduct electricity are metallic ones and ionic ones. Covalent substances, or liquids, don't tend to conduct. There are a couple of exceptions to this rule, water being one of them, but as you'll learn in acids and bases, that's because water is partially ionic. The water molecule splits up into hydrogen ions and hydroxide ions, so that only conducts because it does have some ionic properties. So in short, metallic substances will conduct, so if there's metallic bonding in the substance, it'll conduct as a solid or as a liquid or molten in solution. If it's ionic, it won't conduct as a solid, but it will as a solution or a liquid. And if it's covalent, it won't conduct at all. As far as these questions are concerned, you don't need to worry about water in this instance of these questions. Okay, so that's how we can definitively work out what type of bonding is in a substance, is by testing the conductivity. Other things that can indicate to us what bonding structure a substance has is its melting point or boiling point. So if you've got a metallic substance, generally the melting point is quite high. Ionic is also quite high. For these ones, you really need to test the conductivity to be able to tell. It's really hard to tell the difference between the melting or boiling points. For a covalent network, it will have a very high melting point or boiling points, like above 1000 degrees. So they're usually quite easy to spot from the melting boiling point information, but you would also be looking to test the conductivity as well, and you'd be looking for no as a solid and no as a liquid or in solution. And then the other covalent type, so if a substance has covalent bonding and it's not a covalent network, then it will be a covalent molecule, and they have very low melting and boiling points, so like below 200 degrees-ish. And again, you can identify them quite easily from their melting boiling points, but you would also be looking for the conductivity to be no and no to make it definitive. Okay, so these are the ways that we kind of work out what type of bonding is in a substance through experimentation. Like I said, if you know what elements are in it, you can kind of make a good educated guess as to what the type of bonding will be just based on what those atoms are. So if you've got a metal and a non-metal, it's most likely going to be ionic. If you've got two non-metals, it's most likely going to be covalent. And if you've got metals only, then it's most likely going to be metallic. So first of all, look at the types of elements that are in the substance and have an educated guess, make an educated decision on what the bonding would possibly be. But to be 100% sure and definitive, you would always want to do the tests. So test the conductivity and test the melting point, and these would be the results that you'd be looking to get. So I hope that helps you a little bit with bonding. If you found it useful, please give it a like. Don't forget to subscribe. Tell all your chemistry friends, and I'll see you again soon.